Hi everyone, this is Arfin, and today we are going to calculate value at risk by using standard deviation volatility and by using volatility through EWMA, which is exponential weighted moving average. So in the previous video, we have already calculated volatility through EWMA method, and now we are going to use that vol in our calculation of value at risk. So let's do it. So first we are going to import libraries, import pandas as STD, import numpy as np, import pandas underscore data reader as web, from scipy import as tabulate, import tabulate. Let's run this. Okay, so we are going to download data. Data is equal to web dot data reader. So what I'm going to do is I'm going to perform this analysis only for one stop right now, and after that I'm gonna automate a function or create a function basically which will calculate VaR through EWMA and VaR through standard deviation. So let's do it. So Apple data source Yahoo, start date 1st 2020 and 31st 2020, and we're gonna use adjusted closing price. Let's run this. Perfect. Let's check the head of the data. Great. So for that we need to calculate a return, and what we are going to do is we are going to calculate data underscore return is equal to np.log data Apple divided by data Apple dot shift 1. Run this so we can check data return. Instead of adding it in the table, I just define a variable and assign all this calculation in this variable. We can also put it in this table, so there is no harm in it to do it in this way or that way. Okay, so we got the return. Now what we are going to do is we are going to calculate volatility through standard deviation, which will be equal to data underscore return dot std, check the vol. Okay, perfect. Let's multiply it with 100, so it will be in terms of percentage, so 2.94%. okay, for EWMA volatility, what I'm going to do is I'm going to save my time and I'm going to take the code from my previous recording, which you can find it there. So I have just taken and pasted here. So series okay, so np dot a range length. Okay, so here it's gonna be length underscore return, because I took it from the for loop, so that's why it's look like this. And okay, so let me run it one by one, so it will be good for us to understand it easily and quickly as well. So let me run this. Okay, so now we have exponential calculation, which I'm gonna change it like this way. So definitely there is no lem. So what is this? Basically it's a decay factor. Lem is equal to 0.94 here, and series we have already defined, and 1 minus lem. So let's run this. There is no error. That's great. And then we have 2 more line. of code. So what I'm going to do is I'm going to just go return, and then let's run this, and similarly let's run this. So we got the number. So here we have a result. Let's copy and paste. So the volatility through EWMA is 1.88. So I'm just going to remove this because I'm going to use it directly there. So I don't want to forget divide this result by 100 in the above calculation, not in the calculation for value at risk. So, okay. So we got the volatility through standard deviation, we got the volatility through EWMA, or we can say vol EWMA. And then let's copy this and paste it here, vol EWMA. So now here we have a VaR is equal to VaR standard deviation, which is equal to vol standard deviation. Okay, so here I didn't calculate the confidence interval. So for that, what I'm going to do is I'm just going to add this. So my CL confidence level will be stats dot norm dot PPF 0. Let's say 99% VaR. We have already calculated standard deviation vol, which is volatility, into CL into, I'm assuming right now the days or holding period is 1 day. So I'm just going to multiply it with 1. Okay. Or in other words, square root of 1. It's gonna be NP dot square root of 1. So let's check the VaR. Okay, let's multiply it with 100. Perfect. So we got the value at risk through standard deviation method, which is 6.84%. Now we are going to calculate VaR through EWMA, which gonna be vol EWMA into confidence interval will remain same, and NP dot square root of 1. So let's run this. Let's check for EWMA. Let's multiply it with 100, and okay, so here we can see the difference. So the value at risk by using EWMA method is 4.38, while the value at risk by using standard deviation volatility is 6.84. Now we are going to automate this function. So for that, what I'm going to do is define for STD consistent. Okay, so what are the inputs we will have? We will have stocks. We will have start date. We will have end date. What else? We will have a TK factor, which gonna be lamb. We will have confidence level. We will have time or days, you can say. Okay, is there any other thing we need to put? I don't think so. If there is anything, we will add it, no worries. So for that, what we are going to do is I'm going to define a data frame. Data is equal to data. Sorry, data is equal to PD dot data frame. And I'm going to download this data. So for that, I already have our data. here, but doesn't matter. Okay, in fact, I'm going to do it data daf. So it's gonna be this gonna be different than this data. Oh, sorry, this data. Okay, so okay, what we are going to do here is web dot data reader, and we have stocks, comma, we have start date is equal to start date. We have end is equal to end date. Okay, and I forgot here, data source is equal to Yahoo, and then start date, end date, and we are going to use adjusted closing price. Perfect. So now I'm going to apply a loop for I in stocks. Now I'm going to calculate a return. So a return will be data underscore return underscore I. Here, instead of data underscore daf I, we remove this I underscore daf. So what will happen whenever we are going to calculate this for multiple stock, we can put it here. Sorry. This. Okay. And then what we have done here is we have calculated return, and then we have calculated volatility. So let's copy this, and vol standard deviation underscore I, so it will be stock volatility, and then it's gonna be daf I dot standard deviation. And then what we have done here is we have generated a series for EWMA. So for that, what I'm going to do is series will remain same, but here instead of return, it's gonna be def of I. So all individual stock return will be calculated here. And okay, I have done a small mistake here. So it's gonna be instead of a data frame, since I have defined it in the function, and it's gonna be df. That's good. I have just noticed this. And okay, so since we have defined data underscore def and data underscore def underscore I, which is gonna be for individual stock, and then in stock name here, similarly stock name here, perfect. And then okay, so here we just need to change it to this, right? Okay, so series will remain same. Why I have assigned this, because maybe there is a possibility that one stock didn't trade in particular times, so the data timeline or the number of rows could be different. So okay, so what I have done here is lambda I have already defined. I'm just going to copy exponential of lambda. So for that, again, exponential will remain same, but here instead of lam in a small letter, I'm gonna make it capital, because in the function I have defined a capital lam, which is lambda, and the rest will remain same. Okay, what else I have done? I have calculated a product. So product will be equal to product underscore I. Why? Because we are calculating or using return here. So data underscore daf underscore I, and then we have squared the return. So each and every single thing I have explained in my previous video of EWMA. So that's why I'm not going to spend a lot of time on a single line. So if you want to understand these line of code and what I have done here in all these line of codes, you can check in my previous video. Okay, so I have calculated product, and then the last one is volatility EWMA. So for that, what I'm going to do is vol underscore EWMA underscore I np dot square root pro underscore I, which is product basically, and then we will get volatility through EWMA. Okay, and after that, what I'm going to do is I'm going to calculate VaR underscore STD underscore I, which will be equal to, so stats.norm.pf, instead of putting the number here, I'm going to put CI, which is confidence interval, into vol vol STD. Let me make sure that I'm selecting the right one. Okay, perfect. Into np.sqrt of this. Okay, so this is our formula for value at risk by using a standard deviation. And similarly, I'm going to do the same thing, EWMA I, which is equal to, I'm going to copy this, and then I'm gonna paste it here. The only thing gonna change here is this line. So it will be vol EWMA I, and the rest will remain same. Okay, perfect. Now we are going to print all this result. Print I comma vol standard deviation into 100 print I comma vol EWMA into 100. In fact, what I'm gonna do is I'm going to print volatility and VaR together. So VaR standard deviation, okay, into 100, and then volatility through EWMA and VaR through EWMA into 100. So let's run this. VaR standard deviation EWMA. We need to pass the list of stocks. So let's say we're gonna do it for Apple right now, and the start date will be 1st 2020. End date 1st 2020. Then we have LAM, which is lambda 0.94. Then we have confidence interval, let's say 99%. And we have days, which is 1 day. So let's run this. Perfect. So we can see that the stock volatility is this, which is 2.94. Here, what we have 2.94. We have 6.84. We have 6.84 VaR. We have 1.88 vol, 1.88 vol, 1.884 and 4.38 VaR, 4.38% VaR. Okay. So instead of printing it in this way, what I'm gonna do is I'm going to print it in the tabulated form. So for that, I'm going to remove all this. And for that, I'm going to create an empty table, which will be a list. Actually, it's not a table, it's going to be a list. Under table here, I'm going to say column is equal to, so I have 4 columns, which is volatility through, let me print it here, so there will be no difference, either I'm gonna put it here or here. So we will have 4 columns. One, volatility through standard deviation, vol through EWMA, VaR from standard deviation, and VaR through EWMA. So what I'm going to do here is I'm going to say I, which gonna be the stock, comma. I'm going to say standard vol standard deviation, comma, vol EWMA, comma, VaR standard deviation, comma, VaR EWMA. And perfect. And I'm going to append this column in this table. So for that, what I'm going to do, table dot append column, and I'm going to return here print tabulate table, comma, headers is equal to. So now I'm going to pass the list of the headers. So what we have here is I, which is the stocks. Then we have volatility through standard deviation. So I'm gonna say vol standard deviation. Then we have vol EWMA. Then we have VaR. Standard deviation. And we have VaR EWMA. And that's it. Let's run this. And perfect. Okay, so what I'm going to do, I'm going to multiply it with 100, 100, 100, and 100. So perfect. Now I'm going to pass some other stock as well. So let's say FB, let's say GM, let's say Ford, all these 4 stocks, and then see how it will look like. Great. And we can change the confidence interval, and we can increase the days. Let's run it again. Perfect. So we have the list of a stock. We have volatility through standard deviation. We have volatility through EWMA. Then we got value at risk through standard deviation and value at risk through EWMA method. So that's all for today. If you have any query, feel free to put it in the comment section below. Hope you like the video. Please like and subscribe my channel, and like this video if it's really helpful for you. Thank you.